Oxford Read and Discover Level 6 Incredible Energy by Louise and Richard Spilsbury. Read by Christopher Ragland. Published and copyright Oxford University Press, 2011. Introduction. Energy is incredible because we use it for everything that we do. Energy can make things work, make things move, and make things happen. People use energy to work and to play. When people do things like cook food, listen to music, and use a lamp, they are using heat energy, sound energy, and light energy. What types of energy can you see here? What type of energy makes televisions and computers work? What types of energy do you use every day?
Discover!
Now, read and discover more about incredible energy. Chapter 1. Energy Everywhere. Energy is everywhere, and energy is in everything. We can't make energy, and we can't destroy it. When we use energy to make something happen, we don't lose it. It becomes a different type of energy. Converting energy. One type of energy can be converted into another. For example, when we move, we use energy from the food that we eat. When runners use this energy to run fast in a race, some of it is converted into heat energy. That's why runners look and feel so hot at the end of a race.
Discover!
When people run, only 25% of the energy in their legs is used to make them move. Most of it is converted into heat energy. Different types of energy. There are many different types of energy. For example, electrical energy and heat energy. Two important types of energy are kinetic energy and potential energy. Kinetic energy is a type of energy that's moving. All things that move have kinetic energy. Wind is moving air. We use the kinetic energy in wind to fly kites and to sail boats. Things that are not moving also have energy. Potential energy is stored energy. It's energy inside something that's waiting to be used. It's energy that has the potential to do work. We have potential energy stored in our bodies. When we run, some of this potential energy is converted into kinetic energy to make our legs move. How potential energy works. When we stretch a rubber band, we give it energy. The energy that we use to stretch the rubber band is stored inside it as potential energy. When we let go of the rubber band, it moves. When we stretch the rubber band more, it has more potential energy, and it can move more. When we jump on a trampoline, this stretches the trampoline springs. This gives the springs potential energy. When the springs can't be stretched anymore, this potential energy is converted into kinetic energy. The springs move back, and this throws us up into the air. From high to low. Some things have potential energy because they are high up. When we lift a picture off the floor and put it on a wall, some of the energy that we use for lifting goes into the picture. If the picture falls off the wall, that potential energy is converted into kinetic energy. When something is very high up, it has a lot of potential energy. The water at the top of a high waterfall has a lot of potential energy. When it falls, it moves very fast because it has a lot of kinetic energy.
Discover!
Angel Falls in Venezuela is the highest waterfall in the world. The water falls almost 1 kilometer from top to bottom. Chapter 2. Heat Energy. We use heat energy for many things. Heat energy makes our homes warm, cooks our food, and makes hot water that we can use for drinking and washing. How we get heat energy. We can get heat energy in different ways. Heat energy from the sun makes Earth warm. We can also get heat energy when we burn wood. When things move, some kinetic energy is converted into heat energy. Inside our body, we make heat energy to keep us warm. When heat is added to something, its temperature gets higher. When something has a high temperature, it's very hot. Things are cold when they have less heat energy. When something is cold, it has a low temperature. Inside hot things. Everything in the world is made of parts called atoms. Atoms join together to make molecules. Atoms and molecules are so small that we can't see them, but they are inside everything: rocks, water, air, and people. When water is frozen, it becomes solid ice because it has very little heat energy. Molecules in ice are very near each other, and they don't move very much. When heat energy is added to something, it makes the molecules inside move more. When heat energy is added to ice, molecules inside it move more. The ice melts and becomes liquid water again. If more heat is added to the water so that it boils, the molecules move so much that the water changes into a gas called steam. How heat energy moves. Heat energy doesn't stay still. It moves from things that are warmer to things that are cooler. When heat moves between things that are touching, it's called conduction. Heat moves between two things until they are the same temperature. Heat moves quickly and easily through some materials, like metal. For example, heat from a stove moves quickly through a metal pan to heat the food inside it. When we pick up a metal spoon from a table, it feels cold because heat moves from our fingers into the spoon. Heat moves slowly through other materials, like wood. We use wooden spoons to stir food so that heat from the pan does not move into our hands. Insulators. To keep our homes warm when it's cold, we have to stop heat energy moving from the inside to the outside. In cold countries, people put insulators in the roofs of their homes. Insulators are materials that stop heat moving from warm places to cold places. Insulators in a roof stop heat moving from the rooms inside the home to the cold air outside. Heat moves slowly through air, so air can be used as an insulator too. When we wear a jacket in winter, the jacket holds air next to our body. The air stops heat leaving our body, and so it helps to keep us warm. Chapter 3. Sound and Light. Sound and light are types of energy that travel in the air. We use sound energy to hear, to listen to music, and to communicate by telephone. We use light energy from the sun to see during the day, and light from lamps to see when it's dark. Sound. Sound happens when something vibrates. When we hit a drum, it vibrates, and this makes the air around the drum vibrate too. The vibrations of sound travel through the air in all directions. These movements are called sound waves. Sound waves are invisible. We can't see them. We hear the sound of the drum when the sound waves reach our ears. Radio waves. Sounds lose energy and get weaker when they move. That's why we can only hear people speaking if they are near us. To send sounds from one place to another, sound waves are converted into radio waves. Radio waves are a type of energy that can travel a long distance through the air. Like sound waves, radio waves are invisible. When you use a cell phone, the phone converts sound waves into radio waves. It sends the radio waves to a cell tower near you. The cell tower sends them to a base station that sends them on to a cell tower near the person you are calling. Their cell phone converts the radio waves back into sound waves so that they can hear you. Light. When something is luminous, it gives off light. Lamps, candles, fires, televisions, and the sun are luminous. Light energy travels from luminous things in straight lines. Light can move through transparent things like air, water, and windows. It can't move through opaque things like walls, trees, or people. Shadows happen when something opaque stops light moving through it. Shadows happen on the other side of an opaque thing where light can't reach. For example, when we stand outside on a sunny day, we block the sunlight and we make a shadow. Some transparent materials can make a thin shadow because they stop some light. Lasers. A laser is a type of light that we get from machines. It's a very thin beam of light that has a lot of light energy and heat energy. Lasers have more energy than sunlight. We use lasers in many machines, like CD players and DVD players. Lasers have so much energy that some factories use them to cut through metal, and doctors use lasers to operate on some parts of the body, like eyes.
Discover.
In clothes factories, people use lasers to cut through hundreds of pieces of fabric at the same time. Chapter 4. Chemical Energy. Chemical energy is a type of potential energy. Wood and gasoline have chemical energy. Chemical energy is very useful because we can convert it into many other types of energy. Using chemical energy. When a material has chemical energy, we call this material fuel. Fuels like wood and gasoline have a lot of chemical energy. When we burn gasoline in a car engine, chemical energy from the fuel is converted into kinetic energy that makes the car move. When we burn wood in a fire, chemical energy is converted into heat energy to keep us warm.
Discover.
The engine in a rocket converts chemical energy from fuel into kinetic energy to send the rocket into space. Fireworks. Inside a firework, there are powders that use chemical energy in different ways. When we burn a firework, these different types of chemical energy are converted into an amazing, colorful display of kinetic energy, light energy, and sound energy. The first thing that burns in a firework is fuel. This gives us the kinetic energy that sends the firework up into the sky. Then, different metals start to burn, and they make sparks of different colors. For example, when copper burns, it makes blue sparks. Some chemicals inside the firework make loud sounds when they burn. Food energy. Food has chemical energy too. Our body converts the chemical energy in our food into chemical energy that we can use to live, to move, and to grow. The chemical energy in our food, and in the food that other animals eat, comes from plants. Food chains. Plants convert light energy from the sun into chemical energy that they can use as food. Plants also store chemical energy. When an animal, like a gazelle, eats plants, it uses some of the chemical energy from the plant. When a lion eats a gazelle, it uses some of the chemical energy from the gazelle's body. When energy from food moves from one living thing to another like this, it's called a food chain. Chemicals in the ocean. Most food chains start with energy from the sun, but some food chains in the ocean start with a different type of energy. The rock under deep oceans is very, very hot. When water goes underground through small holes, The rock makes the water as hot as the inside of a pizza oven. The hot water dissolves some of the chemicals in the rock. So the chemicals become part of the water. When water with chemicals dissolved in it comes out of the rock, living things called bacteria feed on the chemicals. Other animals in the ocean feed on the bacteria.
Discover.
Deep in the ocean, some bacteria live inside the bodies of giant worms that can be 3 meters long. The bacteria make food for the worms. Chapter 5. Electricity. How often do you use televisions, lights, and computers? Without electricity, these and many other machines can't work. Electricity is a very useful type of energy that gives us heat energy, light energy, sound energy, and kinetic energy. What is electricity? Inside atoms, there are parts called electrons. Electrons can move from one atom to another, and when they do this, they make electricity. Lightning is a type of electricity. It happens when the wind makes atoms of ice inside clouds move around and crash into each other. Electrons move quickly from one atom to another, and we see this movement of electricity as a flash of lightning. How electricity moves. Power stations are factories that make electricity. The electricity goes through cables and pylons to our homes. This electricity makes the machines in our homes work. Some materials are called conductors. Electricity can move easily through these materials. Most metals, like copper and gold, are good conductors. This is why electricity cables are made of metal. Other materials, like rubber and air, are called insulators. Electricity can't move easily through these materials.
Discover.
Some animals are dangerous because they make their own electricity. Electric eels store electricity in their body and use it to kill other fish. Using electricity. Electricity gives us different types of energy. In a toaster, electricity is used to make heat energy to cook bread. Wires inside a toaster are made from a type of metal that slows down the electricity, so that some of its energy is converted into heat. In a hairdryer, electric wires give us heat energy, and then electricity turns a fan. The fan uses kinetic energy to push the heat out of the hairdryer so that we can dry our hair. In many electric lamps, electricity moves slowly through a thin, curly wire inside a light bulb. This makes the wire so hot that it becomes white, and it glows to give us light.
Discover.
Most of the electricity that moves through the wire in a light bulb is converted into heat, not light. Using batteries. Some machines, like calculators and music players, use batteries for their electrical energy. Batteries only give us small amounts of electricity, but they are useful because they can store electricity to use in machines that we take with us when we travel around. Small batteries are useful in small machines like watches. Bigger batteries have more potential energy, and we can use them in machines like flashlights. Some machines need 2 or more batteries. Batteries store chemical energy. The chemical energy is converted into electricity when we turn on a machine. The chemicals inside a battery are dangerous, so never play with a battery or open a battery. Chapter 6. Fuels for Energy. Coal, oil, and gas are fossil fuels. We use fossil fuels and nuclear fuels to make electricity. We use fossil fuels to heat homes and to power cars, buses, and trucks. Fossil fuels. Fossil fuels are made from plants and animals that lived on Earth millions of years ago. Coal was made like this. When giant plants in ancient jungles died, they sank into mud. Slowly, over millions of years, the mud became hard and changed into rock. The heavy rock pressed down on the plants, and heat from inside Earth helped to change the plants into black coal. Oil and gas were also made like this, but they come from animals that lived in ancient oceans. Getting coal. Miners are people who get coal from under the ground. They use machines to cut holes and tunnels in the ground. Then, they cut pieces of coal out of the rock from under the ground. Trucks and trains take coal to power stations or to people's homes where the coal is burned to give us heat. Getting oil and gas. People get oil from oil rigs in the ocean, and they get gas and more oil from wells on land. The oil and gas move through long pipes to where people need it. People mostly use gas for heating and cooking. They usually use oil to make gasoline and to make new chemicals.
Discover.
One of the longest gas pipes in the ocean goes 1,200 kilometers from Norway to the United Kingdom. Fossil fuels for electricity. Most large power stations use the chemical energy in coal to make electricity. In a coal power station, people use heat energy from burning coal to boil water. The boiling water makes steam that has lots of kinetic energy. The steam turns a turbine. The turbine turns a generator, and this makes electricity. Cold water then cools the steam and converts it back into water. Some water is heated up again by burning more coal to make more steam. The electricity moves through cables to our homes and other buildings where we can use it. Nuclear energy. Nuclear energy doesn't come from fossil fuels. It's a different type of energy. Nuclear fuel is a metal called uranium. We get nuclear energy when atoms inside uranium are broken. Every atom has a part called the nucleus, and this is where nuclear energy is. When a uranium atom breaks open, the energy comes out as heat. When many atoms break open at the same time, large amounts of heat are made. Heat from nuclear energy is used to make steam that turns turbines and generators in a nuclear power station. In nuclear submarines, the steam turns propellers that move the submarine forward. Chapter 7. Problems with fuels. About 75% of the energy that people use for power stations and vehicles around the world is made from fossil fuels. Fossil fuels and nuclear fuels are very useful, but there are problems with using both of them. Non-renewable fuels. One problem with fossil fuels is that they are non-renewable. Fossil fuels are made from plants and animals that lived millions of years ago. When we have used all the fossil fuels that are on Earth now, there will not be any more. Some scientists say that oil will run out in 40 to 70 years, and gas in 50 to 150 years. Coal will run out in about 1,000 years. Dirty air. When fossil fuels are burned, they make different gases that make the air dirty. This is called air pollution. Air pollution is bad for plants, animals, and people. Power stations and vehicles make air pollution. When gasoline is burned in cars and other vehicles, people who are walking or riding bicycles in the streets sometimes start to cough. The problem is worse in cities where there are many cars. In some cities, you can see the air is dirty. Some people wear a mask over their face so that they don't breathe the pollution.
Discover.
There are 700 million cars in the world. There may be 1,400 million in 30 years. How greenhouse gases work. Greenhouse gases are a mixture of gases in the air around Earth. When heat from the sun warms Earth, some of it bounces off Earth and goes back into space. greenhouse gases stop some of this heat going back into space. Greenhouse gases are useful because they store the heat and they keep Earth warm. Without greenhouse gases, Earth would be so cold that we would not be able to live here. Greenhouse gas problems. When lots of fossil fuels are burned, they put too many greenhouse gases into the air. This makes it warmer on Earth, and it can change the world's climate. This is called global warming. Many scientists think that global warming has started forest fires, has created more floods, and is melting glaciers and ice in the Arctic and Antarctic.
Discover.
If polar bears in the Arctic don't have ice to climb onto, they could die. Nuclear problems. The biggest problem with nuclear fuel is that after uranium has been used, it makes dangerous radioactive waste. The radioactive waste stays dangerous for hundreds of years, so it has to be stored very, very carefully. The radioactive waste is invisible, but it's very dangerous, and it can kill living things. Chapter 8. Saving Energy. There are problems with fossil fuels and nuclear fuels, and we need to use more renewable energy. Renewable energy comes from things like wind, water, and sunlight. These are types of energy that will not run out. Solar energy. People use the sun's energy or solar energy to heat water and to make electricity. In some homes, solar panels use the sun to heat water. The panels take heat from the sun, and then they heat the water in pipes. Some types of solar panel have photovoltaic cells inside. The photovoltaic cells convert sunlight into electricity. They can be used in small machines like laptops or on a roof to make electricity. Many photovoltaic cells together can make electricity for thousands of people. Wind energy. Wind is moving air. To catch wind energy, people build wind turbines in windy places like high hills or near beaches. Wind turbines are tall and they have 3 or 4 blades at the top. The blades turn like a propeller when the wind blows on them. The blades then turn a generator inside the wind turbine to create electricity. When many wind turbines are built together to make a lot of electricity, this is called a wind farm.
Discover.
Winds are stronger when they are higher in the sky, so scientists are inventing wind energy machines that look like kites. They send electricity to Earth through long cables. Energy from water. People can use the kinetic energy of moving water to make electricity. For example, water that moves down mountains moves very quickly, and so it has a lot of kinetic energy. In a hydroelectric power station, this water moves quickly into pipes, which push it through turbines. The water turns turbines that turn generators to make electricity. Some hydroelectric power stations are next to rivers. A large wall called a dam holds the water so it becomes a store of potential energy. When the water stored behind a dam is pushed through pipes and turbines, the potential energy is converted into kinetic energy that can be used to make electricity.
Discover.
The Hoover Dam is one of the biggest hydroelectric power stations in the USA. It makes electricity for about 1.3 million people. What can we do? We can all help to save energy. We can use fewer fossil fuels every day by changing some of the things that we do. For example, we can save oil by walking, riding bicycles, sharing rides to school, or traveling by bus instead of making all our journeys by car. This will also reduce the amount of air pollution and greenhouse gases that go into the air. We can use less electricity by turning off lights and electric machines when we aren't using them. In the future, there will be more people on Earth, and we will need more electricity and more energy for our vehicles. What will you do to help to save energy for the future?